Alright, question 17 is very similar to question 16. We're still trying to write an equation in slope-intercept form of a line that passes through this point and is parallel to this equation. The only thing different here is they kind of flip-flopped the x and y terms. Now x is in the middle. But we're still trying to do the same thing. We're trying to get y by itself. We're trying to get y equals mx plus b so we can see the slope. Because we're looking for something that's parallel to this, so we need to know what the slope is. So what we're going to do is still get rid of this x term. So since it's minus 6x, what we do to get rid of it is we add 6x to both sides. Alright, that will cancel this term out. And we're left with this 2y equals, I'm going to go ahead and put this positive 6x in front. 6x. And then this positive 4 behind it. Alright, next I need to cancel out this 2 because right now I have 2 times y and I just want y by itself, so we do that by dividing by 2. Divide each term by 2. So what we do on one side we have to do on both sides. That will cancel this term out. And I get left with y equals 6 divided by 2 will give me 3x. 4 divided by 2 will give me plus 2. Okay, now I can see what my slope is. My slope here is 3. So if I'm looking for something parallel to this equation, it's going to have the slope of 3. So I'll write in 3 here, and it needs to go through the point 3, 5. Alright, so now I have a point, I have a slope. So you should know we can use point slope form. All we're going to do is plug in these values and figure out what our equation is. Alright, so I have y minus y1, my y1 is 5, equals m, my slope is 3, x minus x1, my x1 is 3. Alright, next step here is distribute this 3 inside the parentheses. This left side is unchanged right now. We haven't done anything over there yet. Alright, but 3 times x is 3x. 3 times negative 3 is going to give me negative 9. Alright, last step here is to add 5 to both sides to cancel out this minus 5. So I'm going to add 5 to both sides. That will cancel out this term here. And I get y equals 3x. Negative 9 plus 5 gives me negative 4. And that is our answer. This equation in slope-intercept form is parallel to this equation, has the same slope, and it goes through the point 3, 5. Okay, question 18. We're only changing one thing on this problem. We're still trying to write an equation in slope-intercept form of a line that passes through a point and an equation, but on this particular problem, they want us to find a line that's perpendicular to this equation, not parallel. Okay, so first we have to know what perpendicular means. That means that their slopes are going to be opposite reciprocals. So opposite reciprocals, we've talked about them a lot in class, but I'll do a few more examples so you guys can see. If we had a slope of 1/2 and we wanted to take the opposite reciprocal, the opposite part of this means the power of it. Since this is positive, we're going to do the opposite, so we're going to change it to negative. And then reciprocal means that we flip the fraction. Instead of 1 divided by 2, we're going to have 2 divided by 1. Which negative 2 divided by 1, that equals negative 2. For this next one, we have a slope of negative 3. So if we take the opposite reciprocal, we're going to take the opposite. So instead of negative, we're going to change this to positive. We could think of this as negative 3 over 1. So if we flip this fraction, we're going to have 1 divided by 3. So this would just be positive 1/3. For this next one, we have 7 divided by 4 as our slope. So if we took the opposite reciprocal, we would change it from positive to negative because we're doing the opposite, and then we would take the reciprocal, which is just flipping this fraction. So we'll do 4 over 7. Alright, so let's go back and work our equation and find the slope and then take the opposite reciprocal because we're looking for something that's perpendicular. So with our equation here, we're still trying to isolate y. So we're going to start moving stuff to the other side. So we're going to move this 3x by subtracting 3x since this is positive. So right here, I'm going to subtract 3x from both sides. That's going to cancel out this term here. I'm left with this negative y equals, I'm going to go ahead and put this negative 3x in front, and then this positive 12 behind it. Okay, last step here is we need to cancel out this negative sign, and we can do that by dividing everything by negative 1. That will cancel out this negative sign, and we'll get left with y equals negative 3 divided by negative 1 will give me positive 3. X positive 12 divided by negative 1, we'll just turn this into negative 12. Alright, so normally on like what we did on questions 16 and 17, we use the same slope because we had parallel. We're looking for something that was parallel to this equation. But now we're looking for something that's perpendicular. So we're going to take this slope of 3 and we're going to take the opposite reciprocal. So instead of it being positive, our slope is going to be negative. And you can think of this as 3 over 1. So if we flip this, we'll have negative 1/3. So this is our slope that our equation is going to have that will make it perpendicular to this equation. So our slope is negative 1/3. And our point is 2, 1. 2, negative 1. Alright, from here we have a point, we have a slope. You guys should know we can use point slope form. So I'm going to plug this in real quick. It's my x1, my y1. So y minus my y1, which is negative 1, equals my slope is not 3, negative 1/3. X minus my x1, which is 2. Alright, now since I have a double negative here, this is just going to turn into y plus 1. And I'm also going to go ahead and start distributing this negative 1/3 into my parentheses. Okay, so negative 1/3 times x is negative 1/3 x. And negative 1/3 times negative 2 is going to give me positive because they're both negative. And this is going to come out to 2/3. Alright, the last step here is just to subtract 1 from both sides so I can get y by itself. And you'll get left with y equals negative 1/3 x 2/3 minus 1. You could think of this as 2/3 minus 3/3. And that will give us negative 1/3. So this is our answer. This equation is perpendicular to this equation because the slope is the opposite reciprocal and it goes through this point. Alright, question 19 wants us to write an equation in a slope-intercept form that passes through the point and is perpendicular to this equation here. So I went ahead and filled in some of the work for us already. We know we're trying to get y by itself, so we're going to subtract 2/3 x from both sides. That will cancel out this term. We still have this y equals negative 2/3 x. I went ahead and put this in front. Okay, and then this negative 2 comes out to just minus 2, and I went ahead and put that in the back. Alright, so really this equation was only one step. We already have it in the form y equals mx plus b. So our slope in this case is negative 2/3. But what we want is a slope that's perpendicular. So remember, when we're doing the perpendicular slope, we need to do the opposite reciprocal. So the opposite reciprocal of negative 2/3, we're going to take the opposite, so we're going to change it from negative to positive. Now the reciprocal means we flip it, so we do 3/2. Alright, now that we have our slope of positive 3/2, we have our point, which is negative 3,5. We have a point, we have a slope, use point slope form. Alright, so when I plug in my x1, my y1, and my slope, I'm going to get y minus my y1, which is 5. My slope is positive 3/2. And my x minus my x1, which my x1 is already negative. So when I plug this in, x minus negative 3 is going to turn into x plus 3. Okay, next step is to distribute this fraction into the parentheses. So this left side is going to stay the same, y minus 5. 3/2 times x is going to be 3/2 x. And 3/2 times 3 is going to give me 9/2. You can keep it as a fraction or write it as a decimal. They're still equal to each other. Alright, next we're going to add 5 to both sides to cancel out this minus 5. So add 5 to both sides. Okay, that's going to cancel out this term here. I'm going to get left with y equals 3/2 x. And this right here, 9/2 plus 5 is 19/2. You can keep it as a fraction or you could turn it into a decimal. As a decimal, it would be 9.5. So I guess let me put that in real quick. Get my pen. Alright, so this equation here, go ahead and highlight it. This is our solution. This equation here is perpendicular to the equation they gave us, and it goes through this point. Alright, on question 20, it wants us to identify which equation in standard form passes through this point and is perpendicular to this equation. So this one looks pretty easy at first, but it gets tricky because it wants us to find the equation in standard form. Okay, so first we see that we're looking for something that's perpendicular to this equation. So if we look at our slope of this equation, we know we need to take the opposite reciprocal. So when I do that, the slope we're going to be using, if I take the opposite, instead of negative, it's going to turn positive. And instead of a slope of 5, you can think this as 5/1. We're going to flip that and we're going to have 1/5. Okay, so now I see my slope is positive 1/5, so I'm going to plug in my points. I have y minus y1. Since my y1 is negative, when I plug that in, it's going to turn into y plus 1 because of the double negative. My slope is positive 1/5. X minus x1, and my x1 is 15. Alright, from here I need to distribute this 1/5 into the parentheses. So when I do that, this left side is still going to remain unchanged. I still have y plus 1. 1/5 times x is 1/5 x. And 1/5 times negative 15. We've gone over how to multiply fractions, but I'll go ahead and do this one for you guys so you can see. 1/5 times negative 15. I think this is negative 15 over 1. When we're multiplying, we just multiply straight across. So 1 times negative 15 is negative 15. 5 times 1 is 5. Negative 15 divided by 5 is negative 3. Alright, last step here is to subtract 1 from both sides to cancel out this plus 1. And what we're left with is y equals 1/5 x. Negative 3 minus 1 is going to give us negative or minus 4. Alright, so here's where the problem comes in, because we found our solution, or normally this would be our solution, but they want it in standard form. And when we look at our answer choices, this doesn't match any of them. So there's two ways to go about this. We can try to transform or rearrange this equation into standard form, or we can rearrange these answer choices into slope-intercept form to see which one matches ours. So if we did use this way of rearranging these equations in the slope-intercept form, y equals mx plus b, this is what we would get. I went ahead and did all of them for you so you can see them. And if we look at which one matches ours, let me see here. Okay, if we're looking at these right here, we're trying to see which one matches our equation that we have, we'll see that it's b. B matches ours. Y equals 1/5 x minus 4. So that would be our answer. If you wanted to rearrange this into standard form, you could also do that. So let's try that way now. Okay, so we're going to take our y equals mx plus b, which is y equals 1/5 x minus 4. Okay, and if we look at standard form, the x term is on the same side as y, so we need to move this back over here. So to do that, we're going to subtract 1/5 x from both sides. That's going to cancel out this term here, and I'm going to just bring these down. So I have negative 1/5 x. I still have this positive y here, plus y equals, this canceled out, so all I have left is minus 4. Okay, so now this is in the form ax plus by equals c. You could think of this b as 1. Awesome, dog is barking. Okay, so from here, even if we look at our answer choices, none of them are in this same form. They're still all a little different than what we have. But you can still find the answer from this, what we have. We have negative 1/5 x plus y equals negative 4. The only difference between what we have right now and these answer choices is ours is a reduced form of one of these. That means that there's a number that we can divide each one of these terms by and get our answer. Just for example, if I said 1 plus 2 equals 3, a multiple of this could be 2 plus 4 equals 6. If I took this bottom one and divided each of these numbers by 2, we would get this one, which is what we have. We have a reduced version of one of these. So looking at our answer choices, we already said the answer is B, so let me just explain why it's B. On answer B, if we multiply each of our values by -10 or divide each of these by -10, we would get our answer. So for example, if I divided this by -10, divided this by -10, and also this. Okay, 2 divided by -10 will give me -1/5 x. -10 divided by -10 will just give me y. And 40 divided by -10 would give me this -4. So that's another way you could do it. Okay, a third way you could have done this one is just plugging in the points. If you plugged in, you know your point 15, -1 is a solution. So if you plugged it into each of these, and then going back to the original answer choices to see which one came out, correct. When I plugged in the point in A, I got 740. But in my answer choice, it said I would have got -40. So I would know that would have been an incorrect choice. For B, it actually worked out. If I plugged in the point, I got my answer as 40. So that one was good. On answer choice C, if I plugged in my point, I got 760, which is not what our answer choice said. It said -40. And if I plugged in the point on D, I got 20, which the original problem had 30, so that's not it. So you could have got your answer was B doing it this way, but this isn't always the best way to do it, because from standard form you don't know what your slope actually is, and there could be more than one that would have worked. In this case there was only one, but there could have been other answers that worked. So let me show you an example. Let's say this was one of our answer choices. We plugged in our points. For x we put in 15, for y we put in -1, so this would be 60. -2 times -1 would be +2. So yeah, when we did this one, we would get 62. So we're like, oh, that point worked. That's our answer. But if we rewrote this equation here, 4x minus 2y equals 62, in slope-intercept form, we would get this. And this slope here of 2 is not perpendicular to this equation. So this would have been an incorrect answer. But when we plugged in the points, it worked. So that's why this method isn't always the best way. It could have worked for this particular problem, but it won't always work. Okay, question 21 isn't too bad. You just had to use pretty much a little bit of algebra. Okay. They say, what is the slope and the y-intercept of a line that contains the point -4, 6 and has the same y-intercept as y equals 1/5 x minus 10? So it's saying it has the same y-intercept as this equation. So we know this is already in slope-intercept form, y equals mx plus b. So if we're trying to find our y-intercept, well, I can already see I'm going to have a y-intercept of -10. So already we know our y-intercept is -10. Okay, but now for the slope. We have the y-intercept, so we have a b, and we have a point, so we could say we have an x and a y. So really what we could do is plug all these values in here and solve for m. Usually we solve for b, we're trying to find what the y-intercept is, but in this case we can plug in the y-intercept and then figure out what our m is. Okay, so I'm going to plug in my y, which is 6. My slope is what I'm trying to solve for, so I'm going to leave it as m. My x is -4. And my slope, my b, is -10. Alright, so now I'm going to multiply these two terms together here. So when I multiply m times -4, I get -4m. minus 10. Alright, next I want to get rid of this minus 10. I'm trying to get m by itself to see what it equals, so I'm going to add 10 to both sides. Okay, 10 plus 6 gives me 16 equals negative 4m. This term here got canceled out. Okay, so now I still want to isolate m, so I'm going to divide by negative 4 to get m by itself. So this term here gets canceled out. I get left with m equals 16 divided by negative 4 gives me negative 4. So m equals negative 4. That's my slope. Question 22 says a plane is 18,000 feet above the airport. So it's saying it's 18,000 feet above the airport. And the plane descends. So the word descends, you should know, means that it's going down. So we're going to subtract. And it's saying at a constant rate of 1,500 feet. Okay, so it's going down this much per minute. Okay, so for each minute. We don't know how many minutes, so let's just say m. Hasn't told us yet. Write an equation to determine t, the time it takes in minutes. Okay, so they want us to use t, but that's fine. I put m in there for now. That it will take the plane to reach a height of 3,000 feet. So if it's at this height, it's going down this much per minute. How many minutes would it be for it to reach 3,000 feet? Alright, so this is how we could write our equation. I'll go ahead and put m here so no one gets confused. I'm looking for minutes. Okay, so to solve this, I just have to solve for m. So I'm going to start by subtracting 18,000 from both sides. To 0. Okay, that will cancel out this term here. I get left with negative 1,500 m equals 3,000 minus 18,000 will give me negative 15,000. Okay, so comma. Alright, so now last step here is to divide by negative 1,500. That'll cancel this term out. I get left with m equals negative 15,000 divided by negative 1,500 will give me 10. So our answer, it would take the plane 10 minutes to reach a height of 3,000 feet. Question 23 says, which of the following is a correct description of the function 6x plus y equals 10? So if we look at our answer choices, we're given a lot of points. So if we want to check to see if a point is a correct description or to see if the graph of the function contains certain points, all we have to do is plug them in and see if they equal 10. So if I plug in this point, it does equal 10. So plugging in each of these does give you a value of 10. So these were all good points. If you plugged in these last two over here, these were bad. They gave you different solutions. So for example, if I plugged in 1 for x, I would get 6. And I put in negative 4 for y. 6 minus 4 is 2, not 10. So that's why this point didn't work. Also this one, if I plugged in 10, 10 times 6 is 60, plus 50 is not 10. Okay, so those 2 points didn't work. So these were not correct solutions. Looking at the bottom one, this point did work. But now we need to check the slope, because this answer choice over here gives us that it has a slope of 6, and this one tells us a slope also, but it's kind of in more words. So first let's see what the slope is, and then we'll look at these two answer choices. If we want to find the slope of this, we need to rearrange it in the slope-intercept form. So I'm going to subtract 6x from both sides. And I'll get left with, I'll cancel it out from over here. I'll get left with y equals, I'm going to go ahead and put this in front, negative 6x plus 10. Alright, so now I can see my slope. My slope is negative 6. So coming back to my answer choices and reading choice A, it says my slope is positive 6, which no, I know it's negative 6, so that automatically knocks out that one. So by default, we would say our answer is D, but let's read what it says. It goes through this point, and when the value of x increases by 1, when we're thinking about slope, we know slope is rise over run. Like, for example, when we're trying to graph our slope, we use rise over run. Okay, so what they're saying is when the value of x increases by 1, so when we run 1, the value of y decreases by 6. So decreases, they're saying if we go over 1, we're going to go down negative 6. So they're pretty much telling us that the slope is negative 6, just using more words to describe it. And yeah, our slope is negative 6, so that is our correct answer, D. Okay, question 24, it wants us, or asks, which of these graphs would be parallel to x plus 4y equals 20? Okay, so if we're looking for something that's parallel, we need to know what the slope is, so we need to rearrange this in the slope-intercept form. So I'm going to subtract x from both sides. That's going to cancel this x. Get left with 4y equals negative x plus 20. Alright, last step here is to divide by 4. Okay, that will cancel out this 4 here. I get left with y equals this right here. Even though there's no number here, you could think of this as negative 1x. So we have negative 1/4 x. Positive 20 divided by 4 is positive 5. Okay, so we're looking for something parallel to this. So we're looking for something that has this same slope. So we're looking for a slope of negative 1/4. So if our slope is negative, that means that our line should be going down. Looking at our answer choices, these two right here are positive slopes. So already you should know that those two are not your answer. If we're looking for a slope of negative 1/4, we know that slope is our rise over run. Okay, so if we pick a point and we use our rise over run, we should still be on the line. So for example, let me try this one over here. I'm going to pick, let's say, this point here. And I'm going to rise negative 1, so I'm going to go down 1. And I'm going to run 4. 1, 2, 3, 4. Okay. This, I'm no longer on the line, so this doesn't have a slope of negative 1/4. So let me try this one now. I'm going to pick this point here. I'm going to rise negative 1, and I'm going to run 4. 1, 2, 3, 4. Oh, yeah. This one I'm still on the line. You could even graph this line. It has a y-intercept of 5, a slope of negative 1/4. And if I graph this, let me get my arrow. If I did graph it, yeah, it's parallel. If I graphed it on these other ones, I could even see that it's not parallel just by looking at it. Question 25 isn't too bad. It's pretty simple. It says the following table describes 4 points on a linear function. What are the x and y intercepts of the function? So x and y intercepts, you should already know the x-intercept is where x is some number and y is 0. The y-intercept is where x is 0 and y is some number for x and y. And if you look at a graph of anything, the y-intercept, wherever it is, the x value is 0, and you're just going up to the y-intercept or down to the y-intercept, so the y-intercept will be negative or positive depending on where that point is. For the x-intercept, it's the same thing, only now the y value is 0, and the x value is going to be positive or negative depending on where it is. Okay, so looking at our chart here of points, I see that x is 0 here. When x is 0, that is my y-intercept, so the y-intercept is 8. So let me write that. Y-intercept equals 8. And I see my x-intercept here at the point where y is 0. It's my x-intercept. So my x-intercept equals 4. If you wanted, you could even write it as the point. Let me do that real quick. The point would be, for the y-intercept, 0, 8. For the x-intercept, it would be 4, 0. Number 26 says the cost of a monthly cell phone bill at Phones R Us is $30 plus 8 cents per minute used. The cost of a monthly cell phone bill at Superphones is $25 plus 10 cents per minute used. In a graph of the cost of monthly cell phone bill, what does the cost per minute represent? So it's asking, what does the cost per minute, didn't know how to ellipse there, cost per minute represent? Alright, so what we want to do is write an equation and then look at our cost per minute and see what that represents in our equation. So we're going to try to write an equation as y equals mx plus b. Alright, so y is our output. So once we figure out how much we get charged, our total cost, we'll say that's y. So we're going to see how much Phones R Us charges us. Or Phones R Us, how much our bill would be, we're going to assign that as y. So once we figure out how much they charge, that's our y. Okay. And it says we get charged $30 plus, plus means we're going to add. Okay, so $30 plus 8 cents per minute used. Okay, so 8 cents, if I convert that into dollars, it would be $0.08. This is 8 cents per minute used. So this per minute, I'm going to assign that as x. Okay, so this is almost in the form y equals mx plus b. I have my mx behind my b, so all I'm going to do is switch these. So I'm going to say y equals 0.1 or 0.08 x plus 30. Alright, so now this is my equation in slope-intercept form. So now if I'm looking at what does the cost per minute, well, the cost per minute is 8 cents per minute. So the cost, if I look at that here, isn't that in the position of my slope? Y equals mx. So the answer for this question is slope. The cost per minute represents the slope. Alright, last but not least, number 27. Identify the pair of equations that describes a pair of parallel lines. So by now, I shouldn't have to say it by now, but parallel lines have the same slope. So the slope is going to be the same. I guess I should have put same slope instead of slope same, but it's all good. You get the idea. Same slope. So I see a slope here, see a slope here, and that is not the same. I see a slope here, which there's no number in front here, but you could think of that as just 1x. Over here, there's no number, you could think of that as negative 1x. So 1 is not the same as negative 1. So this one is not it, this one is not it. Let's go to the next one. No number in front of this one either. You can think of this as 1x. This one has a slope of negative 2. Not the same. This isn't our answer. Let's look at this last one. No number value here, but we can think of this as 1x. Over here, 1x. Yeah, 1 is the same as 1. So this is our answer. And your phone's ringing. Better go answer it.